Hi, and welcome to Chapter 4, Section 7. This is the last section of this chapter. So here we go. Today we are talking about integration with inverse trig. So I have listed out all the integration formulas for you. This is just taken from, remember how antiderivatives are just the opposite. So like if we took the derivative of arcsine or arctan or anything like that, then you would get this. And so that's why these are the integration rules for inverse trig. So we're going to be looking at problems where pretty much you're going to see integration in fraction form, but then we want to differentiate between like which formula do we actually use based on the problem that we're given. So here we go. We're going to start off nice and simple here with the integral of dx over the square root of 4 minus x squared. So sometimes you might also see this written like this, where it's like 1 over the square root of 4 minus x squared times dx. Hopefully you understand these two are the exact same thing, because dx, if you multiply it on top, you get the same thing. All right, so either way it's written, we want to basically match this up to one of our formulas here. Another good way to tell that you would have to use inverse trig is because when you actually look at the problem itself, something like this, we would probably use u sub because we have, something that's more complicated on the bottom. So if you try to set u equals 4 minus x squared, when you find du to find the derivative of that, you end up with negative 2x, but like negative 2x doesn't occur anywhere else in the problem, so that would be difficult to cancel out. Or even if you did like square root of 4 minus x squared as u, that still makes it really complicated. So that's how you're going to know, all right, I should be using something with inverse trig, especially if you see that square root on the bottom. So with the square root on the bottom, then obviously I should either be using this first formula or the last one, but the last one has something in front of the square root, so probably not that one. Definitely the first one. So in all of these formulas, a just stands for like a constant. So a is not the variable. For each of these formulas, u is the variable they're talking about, because we can also, use u sub to figure out our formulas. So u is the variable, a is just a constant. So like if you look at our problem, 4 is our constant number here. So a for us would actually be 2, because in the formula, this number here should be a squared. So 2 squared would give us the 4. Okay, and then for u, because I have an x squared here, instead of u would just equal x for us. All right, so once I know those two pieces of information, then I'm just going to follow the formula to integrate. So arcsine of u over a, so u for us is x, over a for us is 2, plus c, that's it. So the antiderivative, or the integral of dx over the square root of 4 minus x squared is going to be arcsine x over 2 plus c. Done. All right, so next, let's try to make this slightly more complicated now. So in this problem, we have the integral of 1 over 2 plus 9x squared dx. And so in this problem, we don't have a square root, but also if we were trying to do u sub with this, u would be 2 plus 9x squared, and then du would be 18x, and 18x doesn't occur anywhere else in this problem, so we can't use u sub here. So looking at our formulas, the only one without a square root is going to be the second one right here, so the one for arctan. So we need to figure out what's a and what's u for us. So in this problem, a should be whatever gets squared to equal 2. So that would be the square root of 2. And then u for us would be whatever gets squared to equal 9x squared. So I can square 3x, and then that'll give me 9x squared. So that means u is going to be 3x. All right, so at this point in time, we notice that u is actually a little bit more complicated. It's not just x now, it's 3x, which means I also need to do u sub at this point. This is our process for u sub now. So the derivative of 3x would be 3 dx, so that means dx would be du over 3. So really, I'm like rewriting my original problem in terms of u so that we can make it look like the formula from above. So this would really be 1 over 2 plus u squared And then dx we said was du over 3. So because I have the du over 3, that's kind of like a constant, so I'm going to move it onto the outside, so that's 1/3 times 1 over 2 plus u squared du. And now it's pretty much in that same form as our original formula. So now I can use the formula, so I still have that 1/3 in front. 1 over a for us would be 1 over the square root of 2. Arctan u is 3x over a, which was root 2, plus c. All right, so just simplifying this out, because I have that 1/3 in front, I just need to multiply it out. So this would end up being 1 over 3 root 2 arctan, and this is a common mistake here. People try to multiply that 1/3 into the arctan number as well, but that doesn't make any sense, because the 1/3 is it's just like a regular number. You're not taking the arctan of it, so it doesn't get applied, or doesn't get multiplied here. So our final answer ends up being 1 over 3 square root of 2 arctan of 3x over square root of 2 plus c. And just in case you were wondering, I don't care if you have radicals on the bottom. We kind of get to ignore that rule now. We're in calculus, so we don't need to rationalize denominators. All right, next example. So now we're doing the integral of dx over x times the square root of 4x squared minus 9. So this time we have the square root on the bottom and we have something in front of this square root, so this most likely is going to be the arcsecant formula. So in order to complete this problem, then we need to figure out what u and a are. So notice this time that it's u squared minus a squared this time, instead of all the other ones where a squared comes first. So that's just one little observation you should probably make. So for us, a is going to be 3, because the constant is the 9, so then 3 squared would give us the 9. U is going to be 2x, because 2x squared will give us 4x squared. Okay. And then keep in mind, at this point in time, we are trying to rewrite this entire problem in terms of u. So the dx needs to be in terms of u. This x in front also needs to be in terms of u. So that's why I'm going to find du to be 2dx, so that I can get dx equals du over 2. And then also, I'm going to rewrite u into terms of x as well. So divide both sides by 2 to get me x equals u over 2. Now I can rewrite the original problem. I just realized I started filming with the mask on. Ha ha ha. I'm not refilming that. All right, here we go. Keep going. So on top, dx, I'm going to rewrite as du over 2. Hopefully the sound didn't make too much of a difference. Oh well. And then the x we're rewriting as u over 2. And then inside the square root we have u squared minus 9. Okay, so now everything's in terms of u. I'm also going to rewrite this problem because I got fractions on top of fractions. This is not pretty. So let's just make this look a little nicer. I'm going to turn this into 1 over u over 2 u squared minus 9 times du over 2. So I'm just moving the stuff on top so that it's not a fraction. That's just being multiplied instead. And then also here I have something divided by u over 2. If you're dividing by a fraction, this is the same as multiplying by its reciprocal. So this is really just 1 over the square root of u squared minus 9 times 2 over u times du over 2. So because I was dividing by u over 2, I'm really just multiplying by the reciprocal of 2 over u, and then that du over 2 at the end. Okay, so writing it out like this, now I see I have things that can cancel out because I've got the 2 and the 2 here, yay. And then I can rewrite this now as 1 over u square root of u squared minus 9 du. Okay, much nicer. So now this looks exactly like our formula, except instead of a squared, we have 9. So that means a is going to be 3, u is going to be u. So this turns into 1 over 3 arcsecant of absolute value of u over 3 plus c. And then we just got to plug u back in. So this will really be 1/3 arcsecant of, and we said u was 2x over 3 plus c. Done. Alrighty. Alright, for this next example, I've got dx over the square root of e to the 2x minus 1. Oh my goodness. Okay, so first, this looks like the first formula, the one for arcsine, because I have square roots on the bottom. I don't have anything in front of the square roots, so cool. So then let's define our a and our u. For this one, usually the constant is supposed to come first, which we don't have, so that's going to be a little awkward. But let's just go with it. So a for us, our constant would be 1, because 1 squared is the 1. And then u for us is, what can we square to get e to the 2x power? So if you square e to the x, you would get e to the 2x, because it'd be e to the x squared. All right. Anyways, so at this point we know u, we have to find du in order for us to complete our u sub. And the derivative of e to the x is still e to the x, so that'll make dx equal to du over e to the x. Okay, this one's kind of special. So specifically for e to the x, just because its derivative is still itself, remember how we're trying to, whenever we find dx, we want something to cancel out with the e to the x. And here we cannot, because e to the x doesn't occur anywhere else. But we also said u equals e to the x. So really, I can rewrite dx as du over u, because I'm just going to substitute u equals e to the x for e to the x here. So now, when I rewrite my original problem, dx is going to be du over u over u squared minus 1. And so I was still able to get my entire problem into terms of u, no more x's. So let me just rewrite this so it looks a little nicer, because if I have du over u, this is the same as 1 over the square root of u squared minus 1 times du over u, which is really 1 over u square root of u squared minus 1 du. So now my problem ends up looking like the arcsecant formula. So, plot twist. Instead of arcsine, it's going to be arcsecant. But we already have everything in terms of u. We know a is 1, so we can use our formula from here. So this will be 1 over, and then we said a was 1, arcsecant of u over 1 plus c. So really this is just arcsecant of the square root of, absolute value of e to the x plus c. And then that's it. Kind of crazy how that one worked out. All right, last example. So this one, we've got the integral of x plus 2 over the square root of 4 minus x squared dx. So first, because I see that I have a square root on the bottom, but maybe I can still use u sub for this, because if I use u equals 4 minus x squared, my derivative is going to be negative 2x, and I do have an x on top, but there's an x plus 2 attached to it, so not quite u sub. All right. And then using one of my formulas, since I have that square root, it kind of looks like the first one, arcsine again, because I don't have the number in front or anything in front of the square root. I just have that x plus 2 on top, which is awkward because in the formula, we're supposed to have like nothing on top, just a du, and that's not what I have. So for this problem, the trick here is because I have this x plus 2 on top and only a square root on the bottom, I can actually split this up into multiple fractions. So that's going to be the trick here. I'm going to split this into x over the square root of 4 minus x squared plus 2 over the square root of 4 minus x squared dx. Because once I split it up, earlier we said if I did u sub on this first one, the derivative would be negative 2x when u equals 4 minus x squared. And that x I can get rid of now, because if the derivative can be canceled out with that top one, that would be great. With the second one, once it's split up like this, this 2 is now really just a constant, so I can move this in front. And And then once it's a constant there, then this will look like our formula. So that's kind of nice too. All right, so let's take this one integral at a time. We'll start with the first one. We said u sub will work for this one because I'm going to do u equals 4 minus x squared. So that du is negative 2x dx. And then dx will be du over negative 2x. Okay, so rewriting my first integral, I'm going to end up with x over the square root of u, and then instead of dx, it'll be du over negative 2x, which is great because the x will cancel out, leaving me with, I'm also going to rewrite this as u to the negative 1/2 power times du, and then that negative 2 that was on the bottom, I'll just write it as a negative 1/2 in front since it's a constant. All right, and that's pretty easy to integrate now using the power rule. So this will end up being negative 1/2 times u to the 1/2 power over 1/2 plus c, which is really just negative u to the 1/2 power, because the 1/2s will cancel out, plus c. All right, so that takes care of that first integral. Now let's deal with the second one. So we said we can rewrite this as 2 integral of 1 over 4 minus x squared dx, which really just looks like the arcsine formula. So that means a equals 2, u equals x, and then we don't have to do du here because if u equals x, this is exactly the same as what we want. Or if you want to think about it as like du is really equal to 1 dx. So du and dx are the same. So this would just end up being 2 times 1 over 4 minus u squared du. So this will end up being 2 times arcsine of u over 2 plus c. All right, now we just need to combine these two things together. So we're going to end up with negative u to the 1/2 power plus 2 arcsine u over 2 plus c. And notice how I didn't write that plus c twice, because c is just that constant of integration. And so whether I add a constant here and then another constant here, or just one bigger number, a bigger constant altogether, that would mean the same thing. So at this point in time, we just need to plug our u back in so that our final answer is going to be in terms of x's again. So we're going to end up with u times, or negative, instead of u, 4 minus x squared to the 1/2 power, or if you want to write that as a radical, cool, plus 2 arcsine of 4 minus x squared over 2 plus c. And there you have it. Done. Yay. Alrighty. That's it for this section. That's it for this chapter. Thanks for watching. Don't forget to like and subscribe. Bye.